Professor, for some reason, I still wasn't able to see the past quiz and test solutions on my Canvas.
Um, I haven't posted the test solution. I'll hold off on that because you don't need that for this test. The quiz solutions I'll post. Um, Test solution I'll post at a later time when you're ready for the final. I'll have all the test solutions posted. Now, if you ever want to review your particular test, I can do that with you. As a short Zoom session if you'd like. I can do that. But I don't want to release any tests right now until the final. There are people out there who are hosting these tests on online systems and so forth, and I'm very wary of letting that out there so that I don't want people to have access to these solutions in the future. So be glad to do it for you as an individual. That would be fine. The quizzes is no problem. I'll post those. All right.
Professor,
It's okay, Kimberly. You can restart. Yes, go ahead. I'm sorry. Amir. Yes, Amir.
so is the test going to be like the last test?
You mean 22 multiple choice questions? Is that what you mean?
Yeah.
Yes. I'm going to review now what will be on the test. Now, one point I also want to make is the recordings. I'm recording from this point forward. I'm going to record on my computer. Today, I'm going to record your own individual review session, but starting next time, I'm going to record just one of the two sessions of statistical literacy. I teach this back to back. So I'm just going to record one of them and then post it to both classes because there's issues with passcodes and things like that the way I've been doing it. And I think if I just record it once and give it to both classes, that should be good enough for recording. So,
Is there a quiz today?
yes, chapters 11 and 12. Yeah, it's on the schedule. I think I've been pretty much on target for the schedule so far. Okay. Any other questions? Oops. All right. So let me review what's in the chapter 7 through 12 will be on the test. I do want to cover the calculations that you need to know. All right. So there's no surprises in that respect. I did have a session earlier today with Excel. Hopefully, all of you can either use Excel or Google Sheets or a calculator. But Excel and Google Sheets seem to be you're able to do. They have the same types of functions for correlation, and also I noticed that it does provide you with functions for slope and the y-intercept of the regression line. So it's just as easy to get those as to get the correlation. I'll show you all three of those. So I can have a question on the slope or y-intercept of the regression line, but it's really easy to do in Excel. It just takes like less than a minute to come up with these things. All right, so chapter 7. Chapter 7 dealt with some different types of summary statistics, such as the mean and the median and standard deviation, and also talked about outliers. We also had some graphs, such as the histogram and the box plot. We also talked about how to calculate the outliers. So I'm going to go over that with you. Now, hopefully all of you know how to calculate the mean, right? It's just the average of a set of numbers. That's pretty easy. And the median is the middle number in an ordered data set. Outliers, of course, are unusually small or unusually large numbers in your data set. I'll go over in a minute how to calculate them, whether it's an outlier or not. In chapter 7, they also had talked about the shape of the distribution, which is important. And let me just go over that for a minute, because this is not only in this exam, they usually test it in the final exam also. So it's an important concept, and it's on page 147. They talked about the difference between a symmetric or bell-shaped curve, a skewed left and skewed right curve. So you need to know, of course, what they look like. And bell-shaped, I think you're all familiar with. Skewed right means that the higher data values are more spread out than the smaller data values. So it's the data is sort of clumped to the left and spread out to the right, and that's why they call it skewed to the right, because it tailed if you drew a curve, it would tail off to the right. And then skewed to the left means that most of the data is to the right and it tails to the left. Now, let's talk about skewed to the right for a minute. Skewed to the right means that there's usually unusually large data values in that data set. And the large values are going to make the mean be bigger than the median. All right. So typically in a skewed right data set, the mean is bigger than the median, and the median is typically bigger than the mode. Remember what the mode is, the most frequent data points. Skewed left means most of the data is to the right, and the smaller data is spread out to the left. So it sort of tails off to the left. That's why it's called skewed left. In that data set, we have unusually small values, outliers, and it makes the mean smaller than the median. So for skewed left, typically the mode is bigger than the median, and the median is bigger than the mean. Okay? So let me just say it one more time. For skewed to the right, okay, the mean is bigger than the median, and the median is bigger than the mode. For skewed to the left, the mode is bigger than the median, and the median is bigger than the mean. Right, so it's important to know those general concepts, not just for this test, but for the final exam. That's why I'm spending some time on that. Okay, what else? Histograms. A histogram. What is a histogram? A histogram is a plot of rectangles for a quantitative or what they call a measurement variable, right? Measurement and quantitative mean the same thing. So usually running along the x-axis is a measurement of a measure of the quantitative variable, and along the y-axis is either one of two things: a frequency, which is a count, which would be the height of the rectangle, or a percentage, which also would be the height of the rectangle. So if it's a percentage, it would mean the count for that rectangle divided by the total count for the whole data set. Okay, that's what percentage means. So if I give you a histogram in a test, I could ask you questions about something like what percentage of approximately what percentage of the data is maybe larger than this value or smaller than this value, or maybe in between two values, something like that. I can ask questions about as far as a histogram is concerned. In addition, in chapter 7 are box plots. Now, box plots are plotted from what's called the 5-number summary. Now, the 5-number summary in the book, they tend to put it inside a box, and then they have these 5 numbers inside the box, with the median on top, and then they have the lower quartile, upper quartile, smallest number, and the largest number. All right, so usually display it that way. So the way they display it is on page 148, the 5-number summary, and then the box plot is a way of also graphing this 5-number summary. And so the box plot basically has a box, and then it has these so-called whiskers that come out on the left and right end of it. Or on the, if it's vertically aligned, box plot would have whiskers coming out from the top of the box and the bottom of the box. They also use an asterisk to indicate what's called an outlier. Now, an outlier, again, is some number that's unusually large or unusually small compared to the rest of the numbers in the data set. Now, on page 150, explain how you create a box plot. Now, in the test, you don't have to create one. If I give you one, I'll ask questions about it. I could also give you two box plots, maybe for two groups of people, and ask you to compare them, right? Compare maybe one part of the 5-number summary to another part of the 5-number summary for each of the boxes, just to compare them. So you basically have to know where the 5 numbers are on the box plot. That is where the smallest number is, where the first quartile is, the median, the third quartile or upper quartile, and also where the maximum number is, and also where the outliers are, because that's where those asterisks are. On page 150, they also talk about what's called the interquartile range. Now, the range of a data set is the smallest number, is the biggest number divided minus the smallest number, right? The largest number minus the smallest number is the range. The interquartile range is the upper quartile minus the lower quartile, okay? Now, in the book, they talk about percentiles. Percentiles are what? There are particular numbers in a data set where if I say the 90th percentile, I mean 90% of the data is smaller than that number. 60 percentile means 60% of the numbers of the data set is smaller than that number. So the quartiles are also percentiles. For example, the lower quartile is the 25th percentile. The lower quartile means that 25% of the data is lower than that. The median is the 50th percentile. It means 50% of the data is below that number. And the upper quartile is the 75th percentile. It means 75% of the data is below that number. Okay. So the interquartile range is a subtraction. It's the upper quartile value minus the lower quartile value. Basically, the length of the box. All right, the box itself is on the left end, or the if the box is arranged horizontally, then the lower quartile is on the left end of the box and the upper quartile is on the right end of the box. If the box plot is arranged vertically, then the lower quartile is on the bottom of the box and the upper quartile is on the top of the box. So the interquartile range is the distance between those two quartiles, and it's the width of that box. In the middle somewhere is the median. Now, if you wanted to calculate if any numbers in your data set are outliers, what you would do is do the following calculation, which is on page 150. You would calculate your interquartile range first. You would then multiply the interquartile range by 1.5. Now, to see if you had any large outliers, you would take the 1.5 times the interquartile range and add it to the upper quartile number. When you do that, you come up with another number. If there's any numbers in your data set that are larger than that number, larger than the upper quartile plus 1.5, the interquartile range, then those numbers are outliers. To find small outliers, you would take the 1.5 times the interquartile range and subtract it from the lower quartile value. And then any numbers in your data set that are smaller than that number are going to be small outliers. But it's all explained on page 150. And that explanation will tell you if any numbers in your data set are outliers. All right, any questions so far? So as far as chapter 7 is concerned, with the 5-number summary or box plots, I can give you a question without the box plot. Okay. and then ask you maybe, not ask you, but maybe to answer a question, you may have to calculate if something's an outlier. Or I can give you a box plot and ask you questions about what you're looking at. Either one of those could happen in your test. Also in chapter 7 are calculations for the standard deviation and the variance. By the way, there are formulas for all of these things at the end of the chapter 7. Somebody in my last class says they don't like using Excel, they want to use formulas instead. Formulas take longer, but you're welcome to use them. There's no requirement that you use Excel. Just a little faster if you know how to use Excel. But the formulas are on page 158 for the mean, for the variance, and for the standard deviation. All of it's there. However, I will show you towards the end of, just before our quiz today, I will show you how to use Excel to calculate the mean and the standard deviation. And also how to, for our for chapter 10, where we're going to look at the correlation and linear regression. I'll show you how to calculate things with that also. All right, that's chapter 7. So some calculations from there. You do have to obviously know some of the concepts in there, but especially with the skewness, the data set. Chapter 8 deals with the bell-shaped curve, right? The symmetric curve. Now, in chapter 8, they talk about percentiles. That's where the definition of percentiles are. In addition, in chapter 8, they talk about standardized scores. So if you have a test, like test scores, for example, you can convert them into standardized scores if you know the mean and standard deviation of the test. For example, if the mean is 100 and standard deviation is 10, and you scored 110 on that test, then you would have a standardized score of 1. The way to calculate it is you take your score, your raw score, that is, and subtract the mean, and then divide by the standard deviation. In this case, you would get a 1. And the 1 would represent how many standard deviations you are larger than the mean, because it's positive, and the 1 represents the number of standard deviations away from the mean. And 110 is 10 units away from the mean. All right, so you need to know that formula. Of course, you don't have to memorize it. It's in the book. You have access to the book, but you should be familiar with it and how to use it. Don't use the test as the initial time that you're using these formulas. So, in addition to that, you should also know how to use what's called the empirical rule. This test, that's on page 173. Now, you may remember that there was a chart on page 175 where it showed the percentiles for the different standard scores. That's usually called a normal table, but for this test, you don't need to use it. It's really not something that is emphasized in this course. But I do want you to know how to interpret a bell-shaped curve when you see it. So the empirical rule helps to do that. And the empirical rule on page 173 says the following. It says that if you take your mean and add and subtract 1 standard deviation from it, all right? In other words, the standard score on the left will be -1, the standard score on the right will be +1. Then there's about 68% of the data in your data set that will be between those 2 points. There's 95% of the data set should be within 2 standard deviations of the mean. That is between -2 standard score and +2 standard score. And then 99.7%, the data set should fall within 3 standard deviations of the mean. That means -3, between -3 standard score and +3 standard score. All right, for this test, that's what you need to know. And what's helpful is on that page, there's a picture of the normal curve. It doesn't have the standard normal curve there, but it shows you as an example what the 68%, 95% mean in terms of the curve. Okay. Now, what if in the test, I give you the following situation. What if I say there's two people taking a test, and I give you the raw score for one of them and the standard score for the other one? And I ask how many students scored between those two scores. Well, one way of doing this problem is to convert the person's raw score, that one person who has a raw score, converted to a standard score by subtracting the mean and dividing by the standard deviation. That way you have two standard scores now to compare. And then, for example, if the one person's standard score is -2, which means they scored two standard deviations lower than the mean, the other person scored 1 as their standard score, and I asked what percentage of the students scored between -2 and 1. The question is, how would you do that? Well, according to the empirical rule, between -2 and 2 standard scores, there is 95% of the data, which means outside of that range, there's 5%, right? 100% minus 95 is 5%. And half of it will be on the left and half of it will be on the right. So if I asked you, for example, what percentage scored of the students scored below -2 standard score, your answer would be 2.5%. Because 95% is between -2 and +2, and half of the difference of 5% is on the left, which is 2.5%. How about the person who scored 1 standard deviation? Well, between -1 and +1 standard deviations, there's 68%, which leaves 32% outside of that range. Half of it, 16% on the left, half of it, 16% on the right. So anybody who scored a 1 standard deviation, there are 16% of the students who scored better than that. All right, so between -1 and 1, we would look to see how people scored outside of that range. To the left, -2, to the left of -2 is 2.5%. To the right of +1 is 16%. You add those two numbers together, you get 18.5%. So 18.5% are outside of the range between -2 and 1. That means 100 minus 18.5% is 81.5% is in between the two. So hopefully all those words made some sense to you. But that's basically how you use the normal curve. All right, because it is symmetric and you can talk about it in those terms. All right, so that's it for chapter 8. You just have to know, again, how to convert a raw score to a standard score. You have to know the empirical rule, how to use it. In the back of chapter 8, I believe during the class when I gave chapter 8, there were some examples of how to use the empirical rule if you wanted to use it. Yeah. Like number 7 on page 177, I showed you how to do that. For example, part A and part C, you don't need to use that table. The empirical rule, you can answer both part A and part C using the empirical rule. All right. So that's it for chapter 8. Chapter 9 gives you some other graphs, such as the pie chart and the bar chart, and what's called a pictogram. Those 3 charts, by the way, are used for categorical data. That's data that is basically labeled data, data that is just describing things, like the type of car in a car lot, or age groups, or whatever it might be, just descriptions or categories. So I'm sure you're all familiar with the pie chart, what it looks like, and the bar chart. Pictogram is just using pictures instead of rectangles as in the bar chart. And you just need to know just some general knowledge about the 3 types of charts in terms of how they're created. You're not going to be asked to create any of these at all, nothing at all. You just have to know how they're being created and what they represent. The rest of the chapter is dealing with quantitative charts, such as the line chart and the time series chart. Remember, the time series chart have these components to it, such as a trend or long-term trend. There's seasonal components to it. And then there's these what are called irregular cycles and random fluctuations. That's about all you need to know for this test as far as chapter 9. Not a whole lot in here. Chapter 10 is a lot more to it. So there's a lot more questions from chapter 10. Chapter 10 is dealing with the relationship between two quantitative variables. So we're going to be talking about correlation. We're going to be talking about regression, the regression line. This is, of course, where it's possible using Microsoft Excel or Google Sheets would be helpful. Again, there's formulas at the end of the chapter, which if you want to use them, you can. They're a little bit lengthy in terms of trying to do them with your calculator, but you can try. If you have a TI-83 or 84 calculator, there are functions on there that allow you to calculate correlation and so forth. For those of you who have that and you want to use your calculator, TI-83, 84 calculator, to do chapter 10 type of questions, you can do that. But since most people are not using that in this course, and I'm not teaching from that, you really need to do your own research, or maybe you already know how to do it, but you need to use your own research and knowing how to calculate correlation using that type of calculator. But I will show you with Excel, since most people have Excel. Now, in chapter 10, they do talk about correlation. Correlation is a number that represents the linear relationship between two quantitative variables. -1, it runs from -1 to +1. Now remember, -1 means perfect negative correlation. That means the line of best fit is sloping downward from left to right. And it means every point on the scatter plot falls perfectly on that line. And as you know, of course, that doesn't happen very often that you see something like that. So, but you can see negative correlations that are close to -1. And this means that the points on the points on the scatter plot fall very close to the line. That's what -1 or a number close to -1 means. Positive correlation means that the line would be sloping up towards the right, from left to right, and +1 means perfect positive correlation. Every dot is right on that line, but again, data is usually not like that. If the data points are very close to the line and it's sloping up, then that's going to be we're going to have a correlation that's close to +1. Most other correlations are between -1 and +1. Correlation of 0 means no relationship, no linear relationship between the X and Y variable. All right? All this information is on pages 206 and 207. And then they give some good examples in the book after that. Now to represent a scatter plot, we can draw what's called a regression line. This is done automatically in Microsoft Excel. You can come up with not only the correlation, but you can come up with the slope and y-intercept regression line. Now, I did mention earlier that I didn't think I would ask a question regarding the regression line, the slope and y-intercept, but I realized that in Excel you can calculate it just as easily as correlation. So I will ask a question like that. I could ask a question like that regarding slope and y-intercept. And again, I'll show you, I'll demonstrate it for you. It's so easy. It's as easy as determining correlation. So the regression line is the line of best fit. It's also called the least squares line. And in the book, they actually give you the Excel functions that you can use for the intercept and slope. And again, I'll show you. And that's on page 213, but I'll show you how to do it in Excel. Again, the regression line's used for prediction. You can come up with another value of X that's not in your data set, plug it in, and come up with your predicted value of Y. Okay, so that's pretty straightforward, what's in chapter 10. And again, I'll show you an example in a few minutes. Chapter 11 just deals with the issues that could come about with correlation. These relationships can be deceiving. You can have correlations that are not legitimate. They have good examples in here. They talk about legitimate correlation does not imply causation. What's important in this chapter, if you go to page 235, it says some reasons two variables could be related. That is, if you have a significant a high correlation between two variables, it could be, according to this, there's 7 reasons why you could have it. Now, one reason could be that the explanatory variable is the direct cause to response variable. Now, if it's an observational study, you can't prove it necessarily. If it's an experiment, and if it's well designed, you can prove it. You have a good chance of proving it. Number 2, and then it gives 7 other reasons, and some of them are like the explanatory variable contributes, but it's not the sole cause of the response variable. We talk about both variables from a common cause. Both variables are changing over time. And they even said it could just be a coincidence. That's a possibility too. Then on page 240, it talks about evidence of a possible causal connection between the two variables. And they give 4 reasons why there could be those relationships. So you need to know, it's good to tag these pages here. I'm just giving you sort of a hint. Again, page 235 and then page 240. Make sure you're familiar with those causes. There could be exam questions related to that. And then chapter 12 is I think the hardest part of the test, right? Unless you find it easy. I can't see why you would find this easy. You're dealing now with the relationship between categorical variables. So you'd have one of these contingency tables that have counts. You have these counts between the two categorical variables. Well, again, I'll show you an example in a minute. So one that we went through in class before, but I'll show it to you again. So in these contingency tables, you can be asked questions like what percentage, for example, if you had, I think there was an example about taking aspirin versus a placebo, whether a person would later have a heart attack or not. So you can ask something like, for the people who took aspirin, what percentage of them had heart attacks? You can ask a question like that. You can ask questions, and by the way, that percentage is also called risk. So you could say, what the percentage of risk does the aspirin group have of having a heart attack? So risk, percentage, proportion, those all mean the same thing. There's also a calculation called relative risk. Again, I'll show you that in a minute. Relative risk. And they talk about baseline risk. You should know what that means. And also odds and odds ratios. You should know how to calculate odds and odds ratios. And so that's pretty much it for chapter 12, but that's a lot, right? There's a lot in there. And they give good examples in here. But I would think for many people, this could be a little bit confusing. So that's why I have the example that I posted for you. So let's actually just take a look at that example. Let me share the screen, and I think I should be able to see it. Yep, it is. All right, so all of you should see this, right? This is the one we went over before, but I'll go over it with you again. So this is a contingency table. There's 2 variables, 2 categorical variables. The ethnic group is one of them. This is the explanatory variable. There's 2 ethnic groups that are being compared, African Americans and people who are white. And then laid off is the other one, whether they were laid off or not. And I believe this this came from a court case where people were thinking there was some discrimination in who was being laid off and who was not. All right, so again, on this is again posted. You can calculate things like for the African American group, okay, this group right here, there's 1,512 of African Americans in this study. 130 of them were laid off, so 130 divided by 1512, if you multiply that fraction by 100, you would get the percentage being laid off as 8.6%. You could express it as the rate, right, per thousand, so it would be 86 per thousand if we multiplied the percentage by 10. Do the same calculation for the white group, 87 divided by 2,900, which is 3%. Okay. And then you can talk about these percentages as risk, the risk of being laid off for an African American, the risk of being laid off for a white American. Now, if you want to know the relative risk, you would just simply take the ratio of these two risks, and it's 2.87. You could say that African Americans are 2.87 times more likely to be laid off than white Americans. You could also express relative risk as a increased risk, right? What does that mean? That means you convert the ratio into a percentage increase. So 2.87, if you subtracted 1 and multiplied that by 100, that would be the percentage increase. Another way of calculating it using this formula here. And anyway, it's 187%. So 2.87 is the factor. It's African Americans are 2.87 times more likely to be laid off. But in expressing it as an increased risk, you would say African Americans have 187% higher risk of being laid off than white Americans. It's another way of saying the same thing. Notice the numbers do not match, right? You have to subtract 1 from the relative risk and multiply it by 100 to get the increased risk. That's the way to calculate it. And then for odds, the odds of an African American being laid off relative to what? Not being laid off. So we go back to the chart. How many African Americans were laid off? 130. How many were not laid off? 1,382. So the odds of an African American being laid off is 130 to 1,382. It's always the yes to the no in this case here. Now, what if I ask the question, what is the odds of an African American not being laid off? Well, it would be the reverse, wouldn't it? It would be 1,382, which is the no, to 130. Okay, so be careful. You have to read it carefully what they're asking for. All right, so those are examples there. Notice that saying the odds of an African American being laid off is this. You could also say the odds of against an African American being laid off, that is, they're not being laid off, is just the reverse. Just reverse the numbers. Same thing with the white American. Odds ratio is simply the ratio of the odds for the two different categories, African Americans and white Americans. You can simply, if you want to know the odds of an African American being laid off versus not being laid off, you can simply divide 130 by 1,382. Okay, remember, 130 divided by 1,382. And you get 0.094. You could say that the odds are 0.094 to 1. Same thing, you could do the same calculation for white Americans. And then you can simply divide these two numbers and you get the odds ratio as 3.03. Since the numerator is referring to African Americans, you would say the odds of being laid off for African Americans is 3.03 times higher than for white Americans. But you can also express this as an increased odds by, again, subtracting 1 from the odds ratio, okay, and multiplying by 100. You could say the odds of being laid off is 203% higher for African Americans than for white Americans. Okay? So this is a good example of what I can ask for chapter 12, all right, these ratios. right? Various ratios. Any questions about that? All right, so we have 5 more minutes. I want to show you this spreadsheet. All right, where are you? Here we go. All right, now ignore what's on the left here. I'm just going to focus on this one. This is one I showed you, I believe, in class on the right. This is we're looking at the relationship between temperature in June and temperature in December for 8 US cities, okay? And we want to see, number one, there's a couple things you can do with this chart, all right? Number one, you can calculate, if you want, the mean and standard deviation for each of these columns. For example, for the June temperatures, if I click this box here, notice it says up here, I'm using a formula. If you're familiar with Excel, you know that you put an equal sign first when you do formulas. The average, the word average is used for the mean. So you type in the word average, and then in parentheses, we would put in the cells where the numbers are in. So you just highlight the cells by holding down on the left clicker of your mouse. Okay. So it runs from N6 through N13. Okay. So that's what I have inside the parentheses for average. Hit enter, and then you get the average is 70.2625. You can round this. If you know the round feature, round function for Excel, you can use it, but I think some people are not familiar with that. So if you wanted to round, you simply just round using the rounding rules that you're familiar with. Standard deviation, whatever I give you is probably going to be a sample, not a population. So this is the function you want to use. You, again, use the equal sign, and then the function you're going to use is stdev for standard deviation, and then .s. The s is representing sample here. So make sure you choose this one, stdev.s, and then you can, of course, highlight the same variables, and you end up with your standard deviation. It's pretty easy to find the mean and the standard deviation using average and standard deviation.s for any column of numbers that you're using. Now, in this case here, in addition, now of course I'm doing the same thing here. This is the mean of this December numbers, and this is the standard deviation of December numbers. Over here, in the right here, we have correlation between these two column of numbers. Again, we use an equal sign. We use CORREL for correlation. That's the function in Excel. In parentheses, we want one column and then comma the other column. So you would use, so N6 through N13 would be the June column. So you would highlight that and then put a comma. And then you would do the December ones like that. So that's how you came up with these inside the parentheses. This is the N6 through N13 is the June numbers, and the 06 through 013 is the December numbers. And you get a correlation of 0.8469 and some other digits there. Now the regression line, the line of best fit. How do you find the slope of it? Well, this number here, just type in slope. Instead of CORREL, use slope, equals slope. And now it's very important with a slope. Actually, let me try it. Let me show it to you again how to do this. In this column, I'm going to put equals here. And I'm going to type in slope. And open up a set of parentheses. Now, notice that it wants the y's to come first. All right, so it's important to know what the y's are. Now, on the test, I will tell you which column is the y's and which one is the x's. The y's are the response variable, the x's are the explanatory variable. But the y's go first. So in this case, let's say December is the y's. So I would highlight that first. Then I would just type in a comma and then put my x's in next. So I would go over to the x column and just go like that. Close the parentheses. Hit enter, and there's my slope, 1.05. If you get them backwards, if you put the x's in first and the y's in next, you'll get the wrong slope. You'll get a slope for the wrong line. So make sure you put the y's in first and then the x's. Same thing for the y-intercept. The function is used as intercept. So you do equal intercept, and you do the same thing. You put your y's in first, and then you put in your x's. Okay. All right. That is the review. I believe it's 4:20 right now. So it's time to start your quiz. All right. If you have any questions, Kiana, you have a question?
Could you do what you just did? Like, is there a possible way that I can do that on a calculator? Because I don't know. Like, that lost me.
Yeah, you can do it. There's formulas at the end of chapter 12. There's formulas. Actually, we weren't doing. Let's see. There's formulas in the book for doing this. Chapter 10, actually, right? Chapter 10. At the end of the chapter, there are formulas for calculating things like that. They're, you can try them, or you can send me send me a message, and maybe I can help you find some other way of doing it. But there are formulas, page 221, that calculates the correlation coefficient, the slope, and the intercept. But it requires a lot of other calculations. It's now. Do you have an 83 or 84 calculator?
No, but I can get one.
Borrow one, and then go on to find a YouTube video that explains how to do regression using your calculator. All right, and it's not hard to do with a TI-83, 84.
Excuse me, Professor. Is this video going to be recorded?
The one I'm doing this video, yeah.
Are you going to do a? Okay.
I'm recording.
It will
right
be
now.
a pre-recording. Okay, and
no,
I can have the code.
There's not going to be a code for this one. This one doesn't require a code. I'm going to post it.
Okay, so I could.
Yes.
Okay.
Yeah, don't worry about it. All right, guys, why don't you start your quiz? It's past 4:20, so go ahead and start it. I'm going to stop the recording.